I'm Evan, and this is the third week of DevOps BootCamp. So this week we're going to be talking about testing and continuous integration. So what are tests? Tests are a way to make sure that your code does what you think your code is doing. So you can test things like normal input to your software and edge cases to your software. So what happens if you pass something to a divide function and it divides by 0? So it's good for making sure that your software handles everything that can be thrown at it correctly. Why is testing important? Why do you want to test? Everybody needs to test. So in 1999, NASA contracted to Lockheed Martin to produce some software for a Mars orbiter. And so NASA produced part of it, Lockheed Martin produced the other part, and then when they combined them together, they didn't do enough testing, and then they sent it to Mars. And it turns out NASA had told Lockheed Martin to use meters and newtons, but Lockheed Martin had instead used feet and pounds. And so the orbiter wound up flying at a quarter of the altitude it was supposed to and wound up disintegrating when it got to Mars. And so everybody needs to test, and it's just incredibly important. So there are several different kinds of testing. There are unit tests, which test individual units of your software, so a certain function or something like that. There's integration testing, which is testing that they all work together within your software. And then there's system testing, which is your software installed on a system, and then testing that whole thing together. So unit tests verify a specific section of code or a function. So this is the majority of the kinds of tests that you're going to be writing, at least for now. So imagine you have an email client that takes a string and returns whether or not that string is a valid email address. So you're going to want a unit test for each possible input. So what happens if I give it something with 2 @ signs? What happens if I give it a character that you're not allowed to have or something like that? There's also integration tests. Integration tests are all of the different components of a software system working together. So if you click the send button on an email client, it's going to be an integration test that verifies that, hey, the to field is an email address, the from field is an email address, and then that the proper function to send email gets called with the proper form data. And then system testing is the last kind of testing when building a system. So system testing comes after you've got your unit tests and they all pass, and you've got your integration tests and they all pass. System testing says we don't care about the software that was written, we just care that it works. So system testing pretends that the system is just this black box. You pass it some input and you make sure the output is the output that you want. Testing frameworks are just libraries that make testing easier. So it's just a collection of handy things that you can use when writing your tests. So you can say, hey, if I call this, make sure that it outputs true, or make sure that it outputs this string. So it's just designed to make your life easier. A lot of languages come with one built in. So today we're going to be talking about Python, and Python has unit test built in. So this is what an example test using unit test looks like. So we have the function at the top is all numbers, which it's a little confusing. It takes all numbers in the response. It uses the map function to say for every thing in response, pass it to string.isDigit, and then return if all of these are true. So you can see in this unit test case down at the bottom half, we have a test numbers class. So this class is a unit test class, which just is going to set up and run these tests whenever we run the unit tests. So we have all numbers, which is a list of strings, all of which are numbers. And then we have not all numbers. And not all numbers is a list of things where some of them are numbers and some of them aren't numbers. And so we can assert true that all numbers is all numbers. And we can assert false that not all numbers are not all numbers. So now it's your turn. We have a function isNumber_prime, which returns true if the number that's passed in is prime. And we have a test and a test class. So it's your job to go to this test class and fill it out. So if you want to work on this, pause the video right now, because I'm about to go solve this test case. Okay, so we're back. This is the test cases. So now we're going to want to write some tests. No. Unit test uses Python classes to define sets of tests. So each individual test inside the prime test case class is within the same set of tests. So what we're going to do is we're going to write a single test, test non-prime. So this is just how you set up a test case with unit test. You say we have a class of something and it inherits from units, and then inside of that we have these functions, these methods, test, whatever, that take the self. Each of these we call assert false, and so then let's pass in non-prime. So is prime. If we close out of here and run the test, and it says it's okay, nothing failed, we're good to go. So now let's test something else. Like what happens if we pass it always need to include test at the beginning of these. That's it. It figures out a little test case that should be run. Assert true is number from, let's say, 5. So now when you run the test, you'll see failed. So it says, hey, so either succeed, fail, or error. And in this case, error because we have a 0 division error. I mean, somewhere in the divide. So error modulo element is equal to 0. So what this is that it's going down this range of numbers. So it starts at the 5 and it goes down to 4, 3, 2, 1, 0. And so if the number modulo the element is 0, which it won't for a prime number, and then it returns false. Then it says, hey, this isn't a prime, because that's how you can tell if something is a prime, is if there's anything lower than it that can go into it. And so what we can do here is instead is something that is divisible by 0, that doesn't exist. You can't divide by 0. Something that is divisible by 1 is still a prime. What we can do instead is we can say, instead of going from 0 to the number, instead we can start at 2 and go to the number. And then we can actually just get rid of this, because now the element will never be 1. So now, if we run these tests, boom, both of the tests pass. So now we're good to go. Okay, so we've implemented those tests and we've fixed a bug or two because the function was written badly. So, but what if something's more complicated than just dividing something? What if it needs to talk to a database or talk to the web or something like that? You don't want your code to fail. You don't want your tests to fail if you don't have access to your production database or if you don't have access to the web. So what you do is you use something called mocking. And what mocking does is it says, I'm going to call this function, but don't actually call it. Instead, just return this. And so you might say, hey, it's going to connect to the web, and it's going to try to get this web page. But instead of going to the web and getting that web page, just return this set of data that we've already downloaded, or just have this database call that we already have. So it's a way of avoiding external dependencies in your tests. There's also setup and teardown. So if your program interacts with a database, maybe it deletes an object from the database and then has to check that the object can be updated. So you don't want each test to affect the other test. So you can have a setup and a teardown. What the setup does is it loads everything into the database in this particular instance, and then the teardown will will clear the database. So each time you run a test, it'll set up, it'll run the test, it'll tear down. And then for the next test, it'll set up, run the test, and then tear down. So it's a way of keeping tests from interacting with each other in ways that they really shouldn't. So testing is nice, but automated testing is even better. So once you've written your test cases, and a way to see that they're still working in the future, like if somebody submits a change and is like, hey, you should include this in your project, a way to make sure that your tests are still passing is to use a continuous integration system. So a continuous integration system like Travis CI or Jenkins, what they do is every time that a change is committed to your code, they will run all of your tests, and then they can also deploy them if you want. And so let's take a look at Travis just a little bit more. So with Travis CI, you can hook it up to GitHub so that whenever you push a project or commit to one of your projects, it will automatically run all of your tests, and then it'll say, hey, these are good to go, or hey, something broke, you should probably check this out. So that's just about all we have. So now you can go to the DevOps Bootcamp exercises and check out the activity for testing.
That
could have gone better, could have gone worse though.
That's why we practice.